Welcome to today's Tech Chat, where I'm diving into the concept of immutability in Python. So, grab your cup of coffee, and let's unravel what makes immutability tick, particularly for someone just starting in the IT field, like you. You know how in Python, variables can often change? Well, in some languages, that's non-stop. But in Python, once you assign a value to a variable, it sticks. No more modifying that variable inside a loop or in the callback of a function unless, of course, we are talking about mutable objects like lists, dictionaries, or sets. But immutable objects are a different story. They're the same old value no matter what. Let's get to know these fixed, unchanging characters in the Python world. First up, integers and floats. Once you calculate the quotient of 24 divided by 7, that's your constant value, and it's not going anywhere. You try hard, but that 3.42857114. It's not going to change. Boom, immutable. String variables are next on our tour. Say you've got a string hello, world, and you've just typed it out. Change it? Not so fast. You can't turn that into hello, universe, within the program's running time. Strings are like that trustworthy friend who won't share secrets ever. But hey, why settle for just strings and numbers? Tuples, you remember these, right? A tuple with values inside. Like Python 3.6, now, tuples are special. They're immutable, but each element can be a wily variable. So, changing a float within the tuple? Totally a no-go, but altering an item within a list, that's a common occurrence and not immutable behavior. Next up, frozen set. It's like a tuple designed to be immutable. But instead of changing individual elements, the whole set in memory remains constant. If an object stores information and won't change, it's considered immutable, like a frozen set containing a couple of items. Now, here's where it gets interesting for data structures. Dictionaries and sets are typically mutable, but if we make copies that point to the exact same information in memory, voila, they become immutable. It's important to note, the memory doesn't create a new dictionary or a list, just an alias to the existing immutable objects. Boom! You've just seen that immutability isn't just a Python concept, it's your new best friend for writing stable code and dealing with concurrent programming. You are seeing this because I thought it important for you, as an IT newbie, to appreciate the role of immutability in Python while dealing with data that must remain unchanged throughout your software's lifespan. You are probably wondering, when do I need to be immutable? Well, imagine a web server handling requests as fast as we can type here. Immutable data types ensure that once a request is processed, the data doesn't accidentally change, causing chaos and confusion in the system processes. It's all about ensuring data consistency and reliability. Remember Python's built-in decorators, memoization, and thread locks. These are some tools to enforce immutability where it's beneficial, especially when you are working on programs needing high performance with many threads working simultaneously. So how do you ensure immutability? Using the tuple constructor to convert mutable data types, or simply refrain from altering those once immutable objects are assigned, is key. Keep an eye on immutable types for those sensitive applications. They're the silent protectors of state in a sea of potentially chaotic concurrency. In summary, understand that immutability in Python is about keeping certain objects constant and unalterable once they're created. Knowing this shifts your focus to using immutable objects wherever consistency is a big deal, like in system programming, data science, web scraping, or database systems handling, and it also opens doors to utilizing more efficient and thread-safe code patterns. I hope this chat filled you in on immutability and its importance in IT. And remember, for more discussions, tips, and tricks, make sure to check out Neeraj's channel TechLab on youtube.io. They got the latest all for you non-tech-savvy freshers like you. Come back often, and don't forget this handy guide. Subscribe to TechLab, you'll thank me later. Catch you on the flip side.